All right, so whenever you go to statdisc.org, you have to sign in, like I said, and then you should see a screen somewhat similar to this. You won't have this data filled in, but it's just like making a list in your calculator. You are going to fill in this data. So notice I used the first column to be my caffeine group, and I filled in all the values there. There were 10 of them, so I should have gone to 10. Oops, 10. And then in the second column, I put in the no caffeine values. So I have those two to compare. So the first thing I'm going to do is go up here to data. It's in the kind of top left, and choose histogram. Data, histogram. And then I have to tell it which column I want. So I want to see the caffeine group first. So I'm going to select the first column. I don't really care about all this other stuff. I am going to change the class width and the class start in a second, because when I click plot, you could tell I get a histogram of 2 bars. That's not helpful. So I'm going to click user defined, the class width. Let's see, I have a range from about 0 to 9, 10 maybe. So I'm going to say maybe a class width of like 3 is probably fine. Well, let's do 2. And then I'm going to have it start at 0, because I can tell that that is my first value that's down here. Then I hit plot. Okay, so now I see a more reasonable histogram. I don't see any like sharp skew or outliers here. We could maybe say it's slightly skewed to the right, but it's not like a ton of data is built up here and then the tail just goes on forever, right? This is pretty a pretty small spread of data. So there's nothing crazy I'm looking at here. So I go back down to my paper and I'm thinking, okay, the first sample distribution shows no strong skew or outliers. So then I come back up and I also need to check the second histogram. So I change my selected column to 2. That was the no caffeine group. Come down and hit plot. Now this time I don't want to start at 0. I need to expand it because I know that there's at least a -2 in there. So I'm going to make it start at -2. There we go. So there's my true histogram I've got going on. So again, I don't see any strong skew. I've only got 10 values. So the fact that it almost looks like there's modes here on the left and the right is not a big deal. We're not worried about this. The data has to look really, really, really bad for this condition to not be met. So we're just gonna check that condition has been met. Okay, so now we're gonna follow these directions. We're going to StatDisc. We're gonna do the analysis button at the top. Click on confidence intervals and then choose a mean of 2 independent samples. So I've already got my data entered, which is nice. So I'm going to go to analysis up here in the top left, choose confidence intervals, and then a mean of 2 independent samples. All right, now I have 2 options up here at the top. I could use summary statistics, so I could enter my mean change and for each group, but I have the data typed in already, so I'm just gonna click use data. Now I have to tell it the confidence level I want. I convert my 95% to 0.95, that makes sense, and tell it the column containing the data. Oh, you know what, I just realized, I'm so sorry. No, this is right. The column containing data for sample 1, there we go. Sample 1, we want column 1. I don't know the population standard deviation, so I just skip that. And generally, you're not going to know the population standard deviation. And then for sample 2, this column containing the data is column 2. I don't need to mess with anything else. This down here on the left, your book discusses these second 2 options, but almost always we say unequal variances. Okay, so then we just evaluate. And here is where our output comes out that we're interested in. Notice it gives you a test statistic, a critical value, a p-value. That's all for hypothesis tests. So we don't need that in this instance, but if we wanted to do a hypothesis test, we could consider that. We're not looking to do that right now. So we're gonna come down here to our 95% confidence interval, and there it is. We're gonna write that down. Okay, so on my paper where it says interval, I'm going to write my -1.30172 is less than mu1 minus mu2 is less than 3.70172. Okay, so normally I would have written this as parentheses, lower limit, comma, upper limit, end my parentheses, but since this is the exact way it's given in this StatDisc output, I wanted to write it down like this. Basically, I have a lower limit and upper limit. Now, this confidence interval tells me since 0, it would be between these 2 values, right? A negative value and a positive value has 0 between them. that there's not evidence that there's actually a difference between them. It's possible that there is no difference at all, zeros between them. I don't know that for sure, but it is possible. Okay, so let's go ahead and make our conclusion. Remember, it's that sentence, we are blank % confident that the interval from blank to blank captures the true blank in context. We're gonna fill all that in. So we are, let's see, our confidence level was 95%. So we are 95% confident that the interval from, let's see, -1, I'm just gonna, let's see, the original values were whole values, so I'm gonna use 1 decimal place and round around to 1 decimal place. So -1.3 beats per minute to 3.7 beats per minute. Remember, that interval captures, because it's the interval that can change, not the parameter. So captures the, let's see, what was our parameter? The true difference in true mean change in pulse rate. Now, I was just copying that part from where I wrote what the parameter was right here. Right, but notice my original problem said the difference in true mean change in pulse rate for subjects like these who drink caffeine versus who drink no caffeine. That's the part we do have to include in our conclusion. Okay, so for subjects like these who drink caffeine. Notice I'm putting caffeine first because that's the way I subtracted. Versus who drink no caffeine. Okay, done. That's my confidence interval. I'm hoping that you like that we're using this StatDisk for the do step. So hopefully you're noticing that most of this stuff is the same. We have a little bit different name for the name of the procedure. And with the experiment, we can exclude that second condition. But other than that, it's pretty similar. So in the next one, we're going to move on to hypothesis test and try to figure out those hypotheses.